Working with Data. This chapter covers using Spring's JDBC template, creating Spring Data JDBC repositories, declaring JPA repositories with Spring Data. Most applications offer more than just a pretty face. Although the user interface may provide interaction with an application, it's the data it presents and stores that separates applications from static websites. In the Taco Cloud application, you need to be able to maintain information about ingredients, tacos, and orders. Without a database to store this information, the application wouldn't be able to progress much further than what you developed in Chapter 2. In this chapter, you're going to add data persistence to the Taco Cloud application. You'll start by using Spring support for JDBC, Java Database Connectivity, to eliminate boilerplate code. Then you'll rework the data repositories to work with JPA, Java Persistence API, eliminating even more code. Section 3.1, Reading and Writing Data with JDBC. For decades, relational databases and SQL have enjoyed their position as the leading choice for data persistence. Even though many alternative database types have emerged in recent years, the relational database is still a top choice for general-purpose data store and will not likely be usurped from its position anytime soon. When it comes to working with relational data, Java developers have several options. The two most common choices are JDBC and JPA. Spring supports both with abstractions, making working with either JDBC or JPA easier than it would be without Spring. In this section, we'll focus on how Spring supports JDBC, and then we'll look at Spring support for JPA in Section 3.2. Spring JDBC support is rooted in the JDBC template class. JDBC template provides a means by which developers can perform SQL operations against a relational database without all the ceremony and boilerplate typically required when working with JDBC. To gain an appreciation of what JDBC template does, let's start by looking at an example of how to perform a simple query in Java without JDBC template. I assure you that somewhere in Listing 3.1 are a couple of lines that query the database for ingredients. But I'll bet you had a hard time spotting that query needle in the JDBC haystack. It's surrounded by code that creates a connection, creates a statement, and cleans up by closing the connection, statement, and result set. To make matters worse, any number of things could go wrong when creating the connection or the statement, or when performing the query. This requires that you catch a SQL exception, which may or may not be helpful in figuring out what went wrong or how to address the problem. SQL exception is a checked exception, which requires handling in a catch block. But the most common problems, such as failure to create a connection to the database or a mistyped query, can't possibly be addressed in a catch block and are likely to be rethrown for handling upstream. In contrast, consider the following method that uses Spring's JDBC template. The code in Listing 3.2 is clearly much simpler than the raw JDBC example in Listing 3.1. There aren't any statements or connections being created. And after the method is finished, there isn't any cleanup of those objects. Finally, there isn't any handling of exceptions that can't properly be handled in a catch block. What's left is code that's focused solely on performing a query, the call to JDBC templates query method, and mapping the results to an ingredient object, handled by the map row to ingredient method. The code in Listing 3.2 is a snippet of what you need to do to use JDBC template to persist and read data in the Taco Cloud application. Let's take the next steps necessary to outfit the application with JDBC persistence. We'll start by making a few tweaks to the domain objects. Section 3.1.1, Adapting the domain for persistence. When persisting objects to a database, it's generally a good idea to have one field that uniquely identifies the object. Your ingredient class already has an ID field, but you need to add ID fields to both taco and taco order as well. Moreover, it might be useful to know when a taco is created and when a taco order is placed. You'll also need to add a field to each object to capture the date and time that the objects are saved. The following listing shows the new ID and create@fields needed in the taco class. Because you use Lombok to automatically generate accessor methods at runtime, there's no need to do anything more than declare the ID and create @ properties. They'll have appropriate getter and setter methods as needed at runtime. Similar changes are required in the taco order class, as shown here. Again, Lombok automatically generates the accessor methods, so these are the only changes required in taco order. If for some reason you choose not to use Lombok, you'll need to write these methods yourself. Your domain classes are now ready for persistence. Let's see how to use JDBC template to read and write them to a database. Section 3.1.2 Working with JDBC template. Before you can start using JDBC template, you need to add it to your project class path. You can do this easily by adding Spring Boot's JDBC starter dependency to the build as follows. You're also going to need a database where your data will be stored. For development purposes, an embedded database will be just fine. I favor the H2 embedded database, so I've added the following dependency to the build. By default, the database name is randomly generated, but that makes it hard to determine the database URL if, for some reason, you need to connect to the database using the H2 console, which Spring Boot DevTools enables at this link. So it's a good idea to pin down the database name by setting a couple of properties in application.properties, as shown next. Or, if you prefer, rename application.properties to application.yml and add the properties in YAML format, like so. The choice between properties file format and YAML format is up to you. Spring Boot is happy to work with either. Given the structure and increased readability of YAML, we'll use YAML for configuration properties throughout the rest of the book. By setting the spring.datasource.generate-unique-name property to false, we're telling Spring to not generate a unique random value for the database name. Instead, it should use the value set to the spring.datasource.name property. In this case, the database name will be Taco Cloud. Consequently, the database URL will be this, which you can specify in the JDBC URL for the H2 console connection. Later, you'll see how to configure the application to use an external database. But for now, let's move on to writing a repository that fetches and saves ingredient data. Defining JDBC repositories. Your ingredient repository needs to perform the following operations. Query for all ingredients into a collection of ingredient objects. Query for a single ingredient by its ID. Save an ingredient object. The following ingredient repository interface defines those three operations as method declarations. Although the interface captures the essence of what you need an ingredient repository to do, you'll still need to write an implementation of ingredient repository that uses JDBC template to query the database. The code shown next is the first step in writing that implementation. As you can see, JDBC ingredient repository is annotated with @repository. This annotation is one of a handful of stereotype annotations that Spring defines, including @controller and @component. By annotating JDBC ingredient repository with @repository, you declare that it should be automatically discovered by Spring component scanning and instantiated as a bean in the Spring application context. When Spring creates the JDBC ingredient repository bean, it injects it with JDBC template. That's because when there's only one constructor, Spring implicitly applies auto-wiring of dependencies through that constructor's parameters. If there is more than one constructor, or if you just want auto-wiring to be explicitly stated, then you can annotate the constructor with @autowired as follows. The constructor assigns JDBC template to an instance variable that will be used in other methods to query and insert into the database. Speaking of those other methods, let's take a look at the implementations of findAll and findById shown in the code sample. Both findAll and findById use JDBC template in a similar way. The findAll method expecting to return a collection of objects, uses JDBC template's query method. The query method accepts the SQL for the query as well as an implementation of Spring's row mapper for the purpose of mapping each row in the result set to an object. Query also accepts as its final argument or arguments a list of any parameters required in the query. But in this case, there aren't any required parameters. In contrast, the findById method will need to include a where clause in its query to compare the value of the ID column with the value of the ID parameter passed into the method. Therefore, the call to query includes, as its final parameter, the ID parameter. When the query is performed, the question mark will be replaced with this value. As shown in listing 3.5, the row mapper parameter for both findAll and findById is given as a method reference to the mapRowToIngredient method. Java's method references and lambdas are convenient when working with JDBC template as an alternative to an explicit row mapper implementation. If, for some reason, you want or need an explicit row mapper, then the following implementation of findById shows how to do that. Reading data from a database is only part of the story. At some point, data must be written to the database so that it can be read. Let's see about implementing the save method. Inserting a row. JDBC template's update method can be used for any query that writes or updates data in the database. And, as shown in the following listing, it can be used to insert data into the database. Because it isn't necessary to map result set data to an object, the update method is much simpler than query. It requires only a string containing the SQL to perform, as well as values to assign to any query parameters. In this case, the query has 3 parameters, which correspond to the final 3 parameters of the save method, providing the ingredient's ID, name, and type. With JDBC ingredient repository complete, you can now inject it into Design Taco Controller and use it to provide a list of ingredient objects instead of using hard-coded values, as you did in Chapter 2. The changes to Design Taco Controller are shown next. The Add Ingredients to Model method uses the injected ingredient repository's findAll method to fetch all ingredients from the database. It then filters them into distinct ingredient types before adding them to the model. Now that we have an ingredient repository from which to fetch ingredient objects, we can also simplify the ingredient by ID converter that we created in Chapter 2, replacing its hard-coded map of ingredient objects with a simple call to the ingredient repository.findById method, as shown next. You're almost ready to fire up the application and try out these changes. But before you can start reading data from the ingredient table referenced in the queries, you should probably create that table and populate it with some ingredient data. Section 3.1.3 Defining a Schema and Preloading Data. Aside from the ingredient table, you're also going to need some tables that hold order and design information. Figure 3.1 illustrates the tables you'll need, as well as the relationships between those tables. The tables in Figure 3.1 serve the following purposes. Taco_order holds essential order details. Taco holds essential information about a taco design. Ingredient_ref contains one or more rows for each row in taco, mapping the taco to the ingredients for that taco. Ingredient holds ingredient information. In our application, a taco can't exist outside of the context of a taco_order. Thus, taco_order and taco are considered members of an aggregate where taco_order is the aggregate root. Ingredient objects, on the other hand, are sole members of their own aggregate and are referenced by taco by way of ingredient_ref. Note: aggregates and aggregate roots are core concepts of domain-driven design, a design approach that promotes the idea that the structure and language of software code should match the business domain. Although we're applying a little domain-driven design, DDD, in the Taco Cloud domain objects, there's much more to DDD than aggregates and aggregate roots. For more on this subject, read the seminal work on the subject, Domain-Driven Design, Tackling Complexity in the Heart of Software, at this link, by Eric Evans. The next listing shows the SQL that creates the tables. The big question is where to put this schema definition. As it turns out, Spring Boot answers that question. If there's a file name schema.sql in the root of the application's class path, then the SQL in that file will be executed against the database when the application starts. Therefore, you should place the contents of listing 3.8 in your project as a file named schema.sql in the src/main/resources folder. You also need to preload the database with some ingredient data. Fortunately, Spring Boot will also execute a file named data.sql from the root of the class path when the application starts. Therefore, you can load the database with ingredient data using the insert statements in the next listing, placing in src/main/resources/data.sql. Even though you've only developed a repository for ingredient data, you can fire up the Taco Cloud application at this point and visit the design page to see JDBC Ingredient Repository in action. Go ahead, give it a try. When you get back, you'll write the repositories for persisting taco and taco order data. Section 3.1.4 Inserting Data. You've already had a glimpse into how to use JDBC template to write data to the database. The save method in JDBC Ingredient Repository used the update method of JDBC template to save ingredient objects to the database. Although that was a good first example, it was perhaps a bit too simple. As you'll soon see, saving data can be more involved than what JDBC Ingredient Repository needed. In our design, taco order and taco are part of an aggregate in which taco order is the aggregate root. In other words, taco objects don't exist outside of the context of a taco order. So, for now, we only need to define a repository to persist taco order objects, and, in turn, taco objects along with them. Such a repository can be defined in an order repository interface like this. Seems simple enough, right? Not so quick. When you save a taco order, you also must save the taco objects that go with it. And when you save the taco objects, you'll also need to save an object that represents the link between the taco and each ingredient that makes up the taco. The ingredient ref class defines that linking between taco and ingredient as follows. Suffice it to say that the save method will be a bit more interesting than the corresponding method you created earlier for saving a humble ingredient object. Another thing that the save method will need to do is determine what ID is assigned to the order once it has been saved. Per the schema, the ID property on the taco_order table is an identity, meaning that the database will determine the value automatically. But if the database determines the value for you, then you will need to know what that value is so that it can be returned to the taco order object returned from the save method. Fortunately, Spring offers a helpful generate key holder type that can help with that, but it involves working with a prepared statement as shown in the following implementation of the save method. There appears to be a lot going on in the save method, but we can break it down into only a handful of significant steps. First, you create a prepared statement creator factory that describes the insert query along with the types of the query's input fields. Because you'll later need to fetch the saved order's ID, you also will need to call setReturnGenerated_keys true. After defining the prepared statement creator factory, you use it to create a prepared statement creator, passing in the values from the taco order object that will be persisted. The last field given to the prepared statement creator is the date that the order is created, which you'll also need to set on the taco order object itself so that the returned taco order will have that information available. Now that you have a prepared statement creator in hand, you're ready to actually save the order data by calling the update method on JDBC template, passing in the prepared statement creator and a generated key holder. After the order data has been saved, the generated key holder will contain the value of the ID field as assigned by the database and should be copied into the Taco order object's ID property. At this point, the order has been saved, but you need to also save the Taco objects associated with the order. You can do that by calling save Taco for each Taco in the order. The save Taco method is quite similar to the save method, as you can see here. Step by step, save Taco mirrors the structure of save, albeit for Taco data instead of Taco order data. In the end, it makes a call to save ingredient refs to create a row in the ingredient_ref table to link the Taco row to an ingredient row. The save ingredient refs method looks like this. Thankfully, the save ingredient refs method is much simpler. It cycles through a list of ingredient objects, saving each into the ingredient_ref table. It also has a local key variable that is used as an index to ensure that the ordering of the ingredients stays intact. All that's left to do with order repository is to inject it into order controller and use it when saving an order. The following listing shows the changes necessary for injecting the repository. As you can see, the constructor takes an order repository as a parameter and assigns it to an instance variable that it will use in the process order method. Speaking of the process order method, it has been changed to call the save method on the order repository instead of logging the Taco order object. Spring's JDBC template makes working with relational databases significantly simpler than with plain vanilla JDBC. But even with JDBC template, some persistence tasks are still challenging, especially when persisting nested domain objects in an aggregate. If only there were a way to work with JDBC that was even simpler. Let's have a look at Spring Data JDBC, which makes working with JDBC insanely easy, even when persisting aggregates. Section 3.2. Working with Spring Data JDBC. The Spring Data project is a rather large umbrella project comprising several sub-projects, most of which are focused on data persistence with a variety of different database types. A few of the most popular Spring Data projects include these. Spring Data JDBC, JDBC persistence against a relational database. Spring Data JPA, JPA persistence against a relational database. Spring Data MongoDB, persistence to a Mongo document database. Spring Data Neo4j, persistence to a Neo4j graph database. Spring Data Redis, persistence to a Redis key-value store. Spring Data Cassandra, persistence to a Cassandra column store database. One of the most interesting and useful features provided by Spring Data for all of these projects is the ability to automatically create repositories based on a repository specification interface. Consequently, persistence with Spring Data projects has little or no persistence logic and involves writing only one or more repository interfaces. Let's see how to apply Spring Data JDBC to our project to simplify data persistence with JDBC. First, you'll need to add Spring Data JDBC to the project build. Section 3.2.1. Adding Spring Data JDBC to the build. Spring Data JDBC is available as a starter dependency for Spring Boot apps. When added to the project's pom.xml file, the starter dependency looks like the following code snippet. You will no longer need the JDBC starter that gave us JDBC template, so you can remove the starter that looks like this. You'll still need a database, however, so don't remove the H2 dependency. Section 3.2.2. Defining repository interfaces. Fortunately, we've already created ingredient repository and order repository, so much of the work in defining our repositories is already done. But we'll need to make a subtle change to them in order to use them with Spring Data JDBC. Spring Data will automatically generate implementations for our repository interfaces at runtime, but it will do that only for interfaces that extend one of the repository interfaces provided by Spring Data. At the very least, our repository interfaces will need to extend repository so that Spring Data knows to create the implementation automatically. For example, here's how you might write ingredient repository such that it extends repository. As you can see, the repository interface is parameterized. The first parameter is the type of the object to be persisted by this repository, in this case, ingredient. The second parameter is the type of the persisted object's ID field. For ingredient, that's string.